connected. If we push a free electron into the copper wire, it will eventually find a new atom to latch onto. The negative charge of that electron will eject another electron from the outer shell, which will then move on to the next atom, and so on and so on. This chain of moving electrons creates a flow known as electric current. Some elements, like copper, aluminum, and gold, can move electrons easily and are known as conductors. We can look at moving charges in another way. Let's say that this tube is a conductive wire and the steel balls are negative electric charges, electrons in this case. We might think that one charged particle needs to move completely through the conductor to create a flow, but that's not actually the case. As we push a ball in one end, the force causes all the balls to move and one pops out the other end. As you can see, one electron, even if it doesn't move very far, can force all the other electrons to move, creating a flow. What we just showed was electric current, which is a flow of electric charge. In most circuits, this is accomplished by moving electrons. The unit for measuring current is the ampere, which is often abbreviated as amps and written with a capital A. 1 ampere is defined as 1 coulomb of charge moving past a point per second. Let's look at a cross-section of wire carrying an electric current. If it takes 3 seconds for 6 coulombs of charge to move through that cross-section, then we say that 2 amps are moving through that wire. Unfortunately, electric current doesn't just magically flow through wires. It needs a little help. If left alone, the electrons in a wire won't move. We need to give them a little push. To do that, we'll use a voltage source like a battery. In a battery, there is a buildup of negative charge on one side in the form of excess electrons. The other side has a buildup of positive charge, an absence of electrons in this case. The charges want to balance out, but the only way to do that is for the excess electrons to flow around the battery through a conductor that we provide. If we connect a piece of wire to the negative terminal, the electrons will push against the electrons in the wire. However, air is an insulator as its molecules do not have very mobile electrons, and it won't readily accept the free electrons. To show this, we'll put a piece of tape at the end of the tube. Now, the electrons at the end of the wire have nowhere to go. Even if we push against the electrons in the wire, they still won't budge. To fix this, we need to connect the other end of the wire to a place where the electrons want to go, and the positive end of the battery will happily accept the electrons.